We've got another 5 questions to work on from the practice test. On this question, we want to evaluate the expression -3 plus 5i plus -3 minus 8i and write the result in a plus bi form. So what we have here is a complex number added to another complex number. And when we add complex numbers together, we need to add the real parts. This is the real part, and this is the imaginary part. So we're going to combine the real parts and the imaginary parts together. So let's write this down. We have -3 plus 5i plus -3 minus 8i. And you might be wondering about those parentheses, why they're there. The parentheses are there to group that real part and the imaginary part together. So in this problem, you can see that the parentheses are only for grouping because there's no operation happening on those parentheses. There's nothing multiplied in the front. There's nothing raised to the power here. So those parentheses are only meant for grouping those terms together. So we can drop those parentheses and we can drop them without being concerned whether we're losing any operations or losing the equivalence. So we're going to add those real parts together. We have -3 plus -3 is -6. 5i minus 8i is a -3i. So we've combined, using addition, those two complex numbers and got -6 minus 3i. For this example, we want to solve the equation square root of x plus 12 minus 10 equals -8. You can see the radical here in our equation, and the radical over the variable makes this a radical equation. When we solve an equation like this, our first step is to isolate the radical on one side. So I want to add 10 to both sides. Once we've isolated the radical, we have square root of x plus 12 equals 2. So we've isolated that radical, and then we want to eliminate the radical. Since we have a square root, the way we eliminate that square root is by squaring both sides. The square root and the square cancel each other out, leaving you with x plus 12. We have 2 squared, which is 4. Now that the radical is gone, we can solve for x. We'll subtract 12 on both sides, and that gives x equals -8. When you have these radical equations, you do need to check to make sure that the answer that you got works in the original equation. So we need to check if -8 works in that equation. Square root of -8 plus 12 minus 10 equals -8. -8 plus 12 is 4. Square root of 4 is 2. And 2 minus 8 minus 10 is -8. So -8 does make the original equation true, and it is our solution. So the reason why we need to do that checking is because when we square both sides, sometimes that produces what we call extraneous solutions. Those are solutions that don't work in the original equation. So every single time you get rid of the radical by squaring both sides or raising both sides to the 4th power or 6th power, you have the potential of getting an extraneous solution. So you need to do that checking step every time you raise both sides to an even power. For this question, we want to find the length of the hypotenuse of the triangle pictured Enter the exact value as a square root, do not round. So we've got this right triangle. Because we have a right triangle, we can use Pythagorean theorem. And Pythagorean theorem is when we have a right triangle, we label the legs of the triangle A, B. The hypotenuse is the side opposite the right angle. We label that with C. And then Pythagorean theorem relates the sides of the triangle to each other. In this way, A squared plus B squared equals C squared. So we have the squares of each leg added up equal to the square of the hypotenuse. So in our picture, this side here is the hypotenuse, which is our longest side, and that's our missing side. We'll label that as X, and 12 and 2 are the legs of our triangle. So we can create the equation 2 squared plus 12 squared equals X squared. 2 squared is 4, 12 squared is 144. 144 plus 4 is 148. I'll solve for x by square rooting both sides. And let's see if we can simplify that radical at all. We actually get plus or minus square root of 148. Every time we square root a square, we get that plus or minus symbol. So let's see about simplifying 148. I'm looking for a perfect square that could divide into 148. My perfect squares are 2 squared, which is 4, 3 squared, 9, 4 squared, which is 16, 5 squared is 25, 6 squared is 36. We'll stop there for now. So in my calculator, I'm typing 148 divided by 4, and that does work. 4 times 37. And so I can write this as plus and minus square root of 4 times 37. The square root of 4 is 2. The 37 stays inside the radical. And I have plus and minus here, but because we're using this as the length, a side of a triangle, we're only going to keep the positive one. We'll throw away the negative one. That just doesn't make sense. So we have the hypotenuse of this triangle being 2 square root of 37. For this question, we want to find all real solutions of the equation 10t squared minus 4 equals 156. Now, as I look at this, I can see that it's a quadratic equation because it's got a t squared as the highest power. But I'm also noticing that I don't have a t term. So a quadratic is when you have ax squared plus bx plus c equals 0. And in this example, we're missing that middle term there. And whenever we're missing that middle term, we can use a method using square roots to solve the problem. I like that method because it's very simple. And with that method, what we do is we try to isolate the square term. Try to isolate this square term here. So let's do that with our problem. I'll add 4 to both sides. That gives 10t squared equals 160. And I'll divide by 10. That's t squared equals 16. Now I've isolated the square factor, and I'm able to cancel out that square factor with the square root. I'm square rooting both sides. The square root and the square cancel. And on the other side, I gain a plus or minus symbol. square root of 16 is 4. So these are my two solutions to the equation, t equals 4 and negative 4. For this question, we want to solve the equation by completing the square. Our equation is y squared minus 10y plus 41 equals 3. So let's first copy down our equation, y squared minus 10y plus 41 equals 3. Now, this question specifies that we want to solve using completing the square. And with the completing the square method, our first step is to isolate just our y terms on one side. So I'll subtract 41 on both sides. That gives y squared minus 10y equals a negative 38. Now, once you've isolated the y terms, you need to check the coefficient on your squared term. It should be a 1 in order to make this method work. In our example, we do have a 1 as the coefficient of our squared term. But if we were to have a number other than 1 there, let's say if this were a 2, you can force that coefficient to be a 1 by dividing every term by 2. So that would force a 1 as the coefficient. But we don't need to do that in this example because our coefficient is already a 1. Once you get your expression or your equation to this state, you're going to find the number that is going to complete the square. Sometimes I like to call that the magic number. So we're going to start with negative 10. We're always going to start with this coefficient of the linear term. And you take that number and divide by 2 and square it. Negative 10 divided by 2 is negative 5. Negative 5 squared is 25. That's our magic number that's going to make the whole problem work out. So we're going to add that number to both sides of the equation. We add it to both sides so that we stay balanced. On the left-hand side, our trinomial is going to factor in a very special way. Y times y is y squared. 5 times 5 gives me 25. I need negatives to create the negative 10y in the middle, and I'll write y minus 5 squared. Y minus 5 times y minus 5 is y minus 5 squared. On the right-hand side, I'll combine those together. Negative 38 plus 25 is a negative 13. And now that I've created that square, I can use the method of canceling it out with a square root. I'll square root the left. To stay balanced, I square root on the right as well. The square root and the square cancel each other out. I'm going to gain a plus or minus symbol on the other side. And the square root of 13, the square root of negative 13, the square root of a negative is I, and the 13 stays inside the radical. I'll solve for y by adding 5 on both sides. We have y equals 5 plus or minus I square root of 13. So we have our solutions to the equation 5 plus I square root of 13 and 5 minus I square root of 13. Thank you for checking out my videos. Have a great day.